As you know, this being a heavy, compact, dense iron magnetic ball, it'd fall very quickly with gravity. So about this length right here, less than a second. Now watch this. I'm going to drop it through this tube. One more time. I'm going to do it with an even longer tube. Here I have another tube. This is aluminum. This one that you saw before was copper. Now with this tube, here, let me first drop the length. About approximately the length of the tube. It's about that. Now with the tube. Now most people that I show this demonstration to, their first assumption is that the magnetic ball falls slower because there is a magnetic attraction between the ball and the tube, the marble I should say, on the tube. And this magnetic attraction causes the marble to kind of slide down the tube. But you'll notice, see it doesn't, I drop right here, it just falls normally. And so there is no magnetic attraction between the magnetic ball and the tube. That's because although this is magnetic, this copper tube is not. This aluminum tube is not. And neither is this aluminum tube. As I said, it's not touching the tube, so it's not friction that causes the ball to fall slowly. So you can see here. Although it may tap it, it's not like it slides down the tube. Here's with the longer aluminum tube. What really causes the magnetic marble to slow down as it travels through the tube is something known as Eddys current. Not Eddie Murphy, Eddy as in E-D-D-Y. Now, according to Faraday's law, a non-ferrous substance such as copper, not magnetic, when its magnetic environment is altered, a potential difference is created within the substance. Therefore, if the magnetic environment of this tube is altered, there will be a temporary potential difference, aka voltage, within that part of the substance, within this part of the tube. Now, this is the magnetic force that causes the magnetic altering in this tube. This ball has a magnetic field. When this magnetic field is traveling through the tube, it causes a potential difference in every spot that the ball travels through. This potential difference in return causes a slight current. This current in return causes a magnetic field. So in a way, this magnetic field is causing all these temporary little magnetic fields as it travels through the tube. Just, for the sake of simpler terms. Now, Lenz's law states that the magnetic field created within this tube by this marble, its polarity opposes the polarity of this marble's magnetic field. That's saying that the little temporary magnetic fields created in this tube oppose the magnetic field of this ball. That is what causes the marble to somewhat float, as you saw. If the polarity of the magnetic field within the tube was the same as the polarity of the magnetic field of this marble, the marble would shoot out. It'd speed the marble up. For the grand finale, I will drop the magnetic marble through this 5-foot long aluminum tube.